Alright, so in this video we are going to look at how to solve some logarithmic equations. In the last video we discussed exponential equations and the fact that in order to solve an exponential equation you use a logarithm. Well, in order to solve a logarithmic equation we are going to use exponents. So here we go. So here we have a problem where we have a single logarithm with a base of 7, and it tells us that 2 log base 7 of negative 2r equals 0. We're going to look at a couple of different ways that we could solve this problem. So the first way is this 2 is an issue. We have to, in order to do the problem, have a logarithm that has a lead coefficient of just 1 in order to take the logarithm and change it into exponential form. In this problem, you can actually take this 2 and deal with it in two different ways, and I will show you both of those. To me, the easiest way to probably deal with it would just be to divide both sides by 2. In that case, we get log base 7, negative 2r equals 0. Now that the lead coefficient is a 1, we can say 7 to the 0 power equals negative 2r. Seven to the 0 is 1 equals negative 2r. R equals negative 1/2. The other option, that in this case would be a little more difficult, but would still work and is worth looking at, is using our rule of logarithm to... So we're going to take that 2 and swing it up into the exponent. So as an alternate method, we'll take that and we'll make it log base 7 of negative 2r squared equals 0. 7 to the 0 power equals negative 2r squared. 1 equals 4r squared. R squared then would equal 1/4. Taking the square root of both sides, we get that r equals plus or minus 1/2. Now, we see over here that r is just 1/2. So by doing this method, we actually ended up with two possible answers. This brings up a very good point. Whenever we work in logarithmic problems, it is important that you plug your answers back in to make sure that they work. So if we did it this method, when we plug our answers back in, we would have, remember, because this is 1/2 and negative 1/2. So I plug the 1/2 back into the original problem, log base 7 negative 2 times 1/2 equals 0. That would give us log base 7 negative 2 times 1/2 is negative 1 equals 0. If you recall, you can never, ever, ever, ever put a negative number inside of a logarithm. So this answer does not actually work. If we plug in the negative 1/2, though, we get log base 7 negative 1/2 times negative 2, which would be log base 7 of 1. And yes, in fact, that does equal 0. So if you have the same logarithm on both sides, this is a pretty simple problem. If the log base 10 of x plus 2 equals log base 10 7, we are not canceling the logarithms, but we can drop the logarithms. So if the interior, because a logarithm is a one-to-one function, if the interior of one would have to equal the interior of the other. Quite simply, this would give us that x plus 2 equals 7, x equals 5. We check 5 plus 2 is 7. There's no negatives inside of a logarithm. You're done. So if you have the same base on both sides, you'll see a couple of problems like that. It really is just as simple as, it's not a cancellation, but if the logarithms are the same, then the internal argument must also be the same. So here we're going to use our combining logarithms property to solve this problem. So the first thing, since both of these are base 3, we need to turn this into a single logarithm. Remember, when we're doing with these logarithm problems, 9 times out of 10, the goal is to just get it to be a single logarithm. So in this case, since we have the sum of two logarithms, that is the product of the single. So we can turn this into log base 3 of x plus 2 times x plus 10 equals 2. Now we have a single logarithm. 3 to the second power equals x plus 2 times x plus 10. So x plus 2 times x plus 10 equals 3 to the second power is 9. Now we're going to just solve this like a regular old quadratic. So I'm going to multiply that out. X squared plus 2x, 10x, 12x, 2 times 10 plus 20 equals 9. Subtract the 9 from both sides. X squared plus 12x plus 11 equals 0. Factor that, and that factors to x plus 11 and x plus 1 equals 0. So x equals negative 11 and x equals negative 1. Now remember, you have to make sure that plugging these in does not put a negative inside of the logarithm on your original equation. If I plug the negative 1 in, negative 1 plus 2 is positive 1. Fantastic. Negative 1 plus 10 is 9. Fantastic. No problems at all. We plug the negative, so the negative 1 is a good answer. But the negative 11 plus 2, that's negative 9, right? Negative 11 plus 2, negative 9. That would put a negative number inside of that. As a matter of fact, negative 11 plus 10 is negative 1. This negative 11 would result in negatives in both of those arguments. And that is why we have to disregard that negative 11, and our answer is just x equals negative 1.